Hey, welcome back, and this is lesson 8.1, and I'm Mr. Bloom. The Pythagorean theorem and its converse, day number 2. Our objective should have been written down on the first day of your notes for 8.1. Students will be able to use the Pythagorean theorem and its converse. So make sure you get that down, check your stuff, make sure you've written it down and you're complete about your solutions. Now, for today, what we're looking at is the theorem 8.2, converse of the Pythagorean theorem. Converse, okay? Theorem, if the sum of the squares of the lengths of two sides of a triangle is equal to the square of the length of the third side, then the triangle is a right triangle. Okay, we're talking about if I'm giving three measures, the smallest two measures squared, if they equal the largest measure squared, then it's going to be a right triangle. And we're saying it works in the Pythagorean theorem. It's a right triangle, okay? Where the smaller two squared equal the hypotenuse, so the largest side squared. Now, part of this, an offshoot of this, when we do this, we got to make sure that we recognize that if I have two values, okay, and the third value for the triangle, this is the is it a triangle. If I have three values, okay, it must meet this requirement. A plus B has got to be greater than C all by itself to be a triangle. This is just to be a triangle. That's got to be true. Okay, so you got to ask yourself, and as we go through, I'll ask you every once in a while, hey, is this a triangle? So we're going to take the smallest two here, 84 and 13. I add them together, and I get 97. Is that bigger than 85? Yeah, so it should be a triangle. But they're asking us in this particular one, is this a right triangle? And if it is, it should work a squared plus b squared equals c squared, where a and b are the smaller two. So I don't care how you assign it, but this was a, this is b. 84 squared plus 13 squared. And I'm wondering, is it equal to 85 squared? Okay. Now, I know 85 squared is 5,725. Okay. But let's check out the other two because I have no idea what they are. All right, so we got 84 squared. That's going to be 7056. 7056. Okay, plus my 13 squared. And 13 squared should be 169. Okay, 169. Put that on another color, 169. Is it equal to, I'm wondering, is it to 85 squared? 85 squared. Hey, 7225. 25. And I lied earlier, I made a mistake. Well, we'll see, we'll chalk that up. So we have these values. If I take 7056 plus 169, that equals 7225. Crazy! So what that means is, since this is also 7225, and this is 7225, that 85, a triangle with sides 85, 84, and 13 is a right triangle by Pythagorean converse. Okay, the converse of the Pythagorean theorem. Okay, so keep that in mind. We just used the converse of the Pythagorean theorem. So by Pythagorean converse, or converse of the Pythagorean theorem, maybe we should do it that way. By converse of Pythagorean theorem. Remember, write those out. I have a solution, and I'm explaining my solution, and I'm supporting it, so it's no longer a question mark. It actually is equal. Okay? If it isn't equal, then it can't be. right triangle by Pythagorean theorem converse. But what could it be? So, ooh, look at what could it be? Oh, look at this. We have theorem 8.3. This is about obtuse triangles. So we're talking about obtuse triangles. Okay, this is an obtuse triangle, check, and 8.4 will be acute. Now, I finished talking about, and when you do this obtuse triangle check if values can make a triangle. Okay, so it was A plus B is that can be greater than C. All right, and we'll talk about that as we go. So now, let's look at this. If the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, then the triangle is obtuse. So if I take those shorter sides and square them and the value together is smaller than the longest, that means it's going to be obtuse. You also see it like this. Shorter two, and this, remember, is the biggest. This is bigger than these two. It's obtuse. Well, in an acute triangle, that same idea, if I square the length of the longest side of the triangle and it's less than the sum of the squares of the lengths of the other two sides, then the triangle is acute. So if I take the smaller two sides and square them, okay, and the longest one squared by itself, if the smaller two squared added together is bigger than the largest one, then it can be classified as an acute triangle. And again, you got to make sure it makes a triangle, the values that are provided. So here we go. Decide whether the numbers can represent the side lengths of a triangle. So we're going to make sure that makes a triangle, okay, where A and B are the smallest sides and C is the largest. So if this is true, this is what's going on. Now, I always have people do this in notes, and I like the idea that we take the acute, we take the right, and we make sure that, you know, if it's acute, this is what's going to happen. If it's just right, that's what's going to happen. If it's obtuse, that's what's going to happen. But make sure it can make a triangle. Make a triangle, okay? Make sure it makes a triangle, especially if you get obtuse. So let's check this out. Letter A, 6 squared plus 8 squared, okay, 10 squared. I'm wondering, is it greater than, equal to, or less than? I'm filling in my circle right there. So I've got 36 plus 64, okay, and 100. Well, this is 100 on the left and it's going to be 100 on the right, so I know they'll be equal. So because they're equal, I've got a right triangle. And I'm using up a lot of space here, so I'm going to make this smaller so I can write my answer in. So 6, 8, 10 makes a right triangle. And incidentally, it's a Pythagorean triple. Now, you guys go ahead and do B. Remember, the smallest two are A and B. The largest one is C. And you're wondering, which symbols go in there? Every time, which symbols? Okay, so now 6 squared plus 6 squared, 10 squared. Well, that's 36 plus 36, that's 72, and 100, and 100's bigger, okay? And let's check to see if it makes a triangle. Is that true? Yes, true. So it's going to make a triangle. All right, so now I look at this, and that's bigger. So if it's bigger like that, nope, it's like that. This has got to be obtuse. Obtuse triangle. Okay, you guys try the next one, 11, 7, and 14. Turn me off and give it a try. So I got 11 squared plus 7 squared, and I'm wondering, what goes in there? And I got 14 squared. I got 121 plus 49 and 196. Okay, remember that's 14 squared, and 121 and 49 is 169, 170. 170, 196. Well, 196 is bigger. Okay, so remember I'm trying to figure that out. So 196 is bigger. It's a bigger triangle. So I'm like, oh, 170 is less than. Okay, the smaller 2. So this is obtuse as well. But you got to check to make sure 11 plus 7, is that greater than 14? And that is true. So this is obtuse. All right, got another obtuse triangle. All right, you guys try D. Turn me off, turn it back on. Okay, welcome back. So I got, remember, I'm doing a squared plus b squared, wondering if it's greater than, less than, or equal to c squared. Okay, that's what I'm doing. I don't know. Okay, so 15 squared plus 36 squared, and I got 39 squared. So those are the numbers I'm running. So let's just check it with my calculator. Notice, I've written down the stuff I'm checking out. Double check your numbers you put in. Holy cow, they're the same. So I know that this is 1521 and this is 1521. So they're equal. This is a right triangle. Now, when we have stuff like E, this gets tricky. But remember, we're squaring these. And this is the square root of 6 squared plus the square root of 8 squared. And we're wondering, is less than, greater than, or equal to the square root of 10 squared. Now, this kind of looks like a Pythagorean triple, except we have square roots in it. But this is 6 plus 8, and is that bigger than 10? Okay, so 6 plus 8, is that bigger than 10? And that's 14 bigger than 10, so this is bigger than, so this is like that. So when I look at that and I check, I'm going to go, well, that's acute. That's an acute triangle. So this is an acute triangle. Okay, I'm going to make this a little bit smaller so I can fit my work in for that next one. Group this together. All right, remember, I'm always using Pythagorean theorem, a squared plus b squared and c squared. And it is wondering what I put in there, okay, for those values. So I've got to make sure what I've is less than, greater than, or equal to. So your turn again. Remember, a squared plus b squared equals c squared, or greater than c squared, or less than c squared. Check it out. 20, 21, 41, greater than 28. Okay, so it's totally going to make a triangle. Now we already did 400 plus 441. Okay, that's 841. Well, I don't know anything about 28 squared, so 28 squared is 784. Well, that's 784. 784, and 784 is far less than that. So I'm looking at if those two legs are greater than the longest one, this is acute again. Okay, last one, you're on. Give it a try. Last two, I should say. Sorry, it's last two. Give those a try. Turn it off and give it a try. Again, Pythagorean theorem, kinda. Remember, wondering which one's bigger, smaller, or equal to. This is 36 plus 100. It's 169. This is 136, 169, and 169 is bigger. Okay, so I know that's true, and since it's bigger, it should be obtuse. Let's double check my notes and go, well, it's bigger, it's obtuse. When I've got the C is bigger, so this is an obtuse triangle. Last one. Okay, our last one. Let's do some green on that one. So I've got 5 squared plus 6 squared and 11 squared. 25 plus 36, 121. That's going to be 61, 121. And this is obtuse, but wait, I forgot a step. Is it going to be a triangle? Because I knew 6 and 10 are bigger than 13 when they add together. 5 plus 6 is not greater than 11. That's not true. So not a triangle. And this will happen all the time, folks. When it evaluates as obtuse, okay, the two smaller sides can't reach the longest side to be a triangle at all. So you got to make sure you're careful and double check. Okay, not a triangle. And we slide on, and our summary today. Our summary today. Objective, students will be able to use the Pythagorean theorem in its converse. And that's what we did. Okay, so now the next thing you got to do is write a couple sentences about something that you learned today about the learning objective. Then rate yourself on a scale of 0 to 4. And just like all the other chapters we've been working on, hey, look, it's a checkoff sheet. Remember 4 is students be able to use law of sines and law of cosines? We'll see about those when we get there. Students be able to use trig ratios, use inverses and everything. That's 3. So our basic stuff is right here in 2. We are looking at our basics. So start looking it over, see what you learned today, and then you can also see what we're going to learn in the next few sections. I hope things are going well. Okay, and if again, as always, if you have a question, please locate your local geometry teacher and ask them, because asking questions will help you with your understanding. Again, I'm Mr. Bloom, and you're not. Have a great day.